Hey guys, Alex from cnc-o-rama here, and today we're going to talk about importing tool holders into Fusion so you can do a little better job of simulating tool paths and hopefully prevent some crashes. So when I first started programming CNC machines, the thought of using a tool holder in simulation just did not seem helpful to me. I was doing all three-axis stuff, and I was like, generally I could just kind of know, but based on the numbers, how deep in Z I'm going and how I'm going to avoid collisions, and it seemed pretty straightforward. As I've gotten more into 4 and 5 axis programming, I definitely see the need for better simulation and how it can really help prevent crashes. But I've kind of gone back, and even in 3 axis machining, I think it's really helpful to have tool holders in there and simulate those. I think for 3 axis, you don't need to simulate your entire machine as you would in 5 axis. But I think the tool holder has kind of become a bare minimum for what you should have simulated for 3 axis tool paths. So the first time I did this, I was using a script from NYC-CNC, and that worked pretty well. It was a little inefficient because it would save a JSON file to my computer, and then I would have to re-upload that as a tool library into Fusion. Today, it's May 2025 when I'm recording this, and I can no longer find that script for download. And Autodesk used to even list that script as the best way of doing this. You can see they have a new way of doing it as of May 2025. So we can look in here, and they're saying to use this Fusion's Essentials add-in, which I agree is actually the better way of doing this. So since I can't even find the script from NYC CNC anymore, and Autodesk is saying use this Fusion Essentials, I think that's the way to go. So we can look over here. So I just did a web search for Fusion Essentials GitHub, found this Kings Mountain Labs thing, and downloaded the code. In Fusion, you're going to go into Utilities, Add-ins, and then this is actually a new dialog box. So if you just add a new script or add in from device, that's the way I did this. So once you add it, you'll have to restart Fusion. A mistake I made the first time I did this is I deleted the Fusion Essentials from my download folder because I thought once I'd ran the add-in, I didn't need that file anymore. But you do need that file saved somewhere safe on your computer. So put it somewhere safe and then do the script or add-in from device. So there is one other option you have that I know of. If you are in the script and add-ins dialog box and you download add-ins from App Store, it'll bring you to this web page, and you can search for Kennametal, and that'll bring you to this. And this only works on Windows. I'm currently on a Mac. I have a Windows computer at work that I use. The last time I tried this, it wouldn't let me import tool holders. It would only let me import tools. I did notice though that there is a version update 1.01 earlier in 2025, and it says they added holders. So hopefully that works. The downside of this is it only works for the Kennametal tools, and Kennametal has a bunch of other brands, so you might be able to find other tools in there. So that might work for you. So for everybody else, we'll be using the Fusion Essentials and working with that. All right, so we're back in Fusion. I'm just going to go into the manufacturer workspace, tool library, and then if we look in the all the way down here, the vendor libraries, I think this is the first thing you should check. It's possible your tool holder you're looking for is already in here. So like if you're using Haas tool holding, there's a bunch of Haas tool holders in here already. So maybe check that first. And while we're in here, first you gotta make sure you have your cloud library enabled. But if we click on this, right click and do a new library, and I want to call this tool holders. So you could have different tool holders. Maybe you have different machines that use different types of tool holders. Maybe you'd want a different library for each of those. But just having that is helpful. All right, so the next thing we need is CAD files for tool holders. So I'm back in design workspace here, and I'm going to go the most basic route, which is to insert a McMaster car component. And you can make this dialog box bigger. So I'm going to search for a Cat 40 tool holder. Let me just download this one. We want to download this as a 3D step file. And I'm just going to take it where it is. Now if I go into my Fusion Essentials and add tool holder, I'm not actually using this tool holder, so I'm just going to call it like test holder. You can put in all your product ID, product link. That stuff is super helpful if you're actually building out a real library. And then this is really helpful. I created a library already called tool holders, so I can put it in there. So my tool library, I'll click this. The axis is just any cylindrical face on here. And then the end face, that's actually the lowest point on your tool holder that matters, I guess. And I'll click OK. Tool added to library successfully, so that's a good thing. So now let's go to our manufacturer workspace. Look in our tool library. And if I look in tool holders, I have this test holder here. All right, so there's one issue with this tool holder. And right here, we're looking at the gauge line. So it thinks the gauge line is way up at the top here. And on a Cat 40, the gauge line is down in here somewhere. So where the diameter of the taper equals 1.75 inches on a Cat 40. So I'm going to change the units in this holder geometry to inches. And right here it says gauge length. So if we know off the top of our head what the gauge length of this tool is, then we're good. Let's say we don't know. So if you look at these diameters, upper diameter, lower diameter, right here it says 1.75. So if I click here, that brings this line to where the 1.75 is. So I know just from experience that that's actually probably not the true gauge line there. It's probably a little bit above here. So let's see. And look at this, there's another 1.75 up here. So I'm pretty sure this is gonna be the gauge line. It looks like the right spot, kind of right at the end of the taper there. And Cat 40 tool holders have a little gap between the spindle nose and the edge of the tool holder here. So that looks right. All right, so this CAD file here, it's kind of up to you. You could just delete this. We don't, now that we have the tool in our library, we don't need this anymore. It might not be a bad idea to save all of these tool holder files in one folder, just so you have them later if you need to ever recreate them. That's probably the better way to do it. But for me, I'm just gonna close this out and don't save. All right, so most tool holder vendors will give you not only the 3D model, but also the gauge length. So in that previous example, if we had the gauge length, all we would do is type that in where the gauge length goes in the tool library there. So I want to look at a different example, Kennametal. So I have this tool holder I want to look up. So this is an HSK tool holder, which is a little different than, well, definitely a lot different than a Cat 40. And what's kind of complicated about this is it has these inserts. So it's actually a shell mill. So how we deal with that is going to be a little bit different, not too complicated though. So let's just look at this. So I already typed in the number I got off the tool holder there. Found this. And then what we can do is create solution. Oh, and by the way, that tool holder was an Ericsson tool holder, but Ericsson is a brand owned by Kennametal. So that's why I'm here in Kennametal looking for this. So we have the tool holder. We can add an item. Let's just look under shoulder mills. And I'm not sure exactly which one this is, but let me just pick, kind of looks like this. So we'll go here. I think it has 5 inserts, so I'm going to go add to solution. We could even go as far as adding the insert. I don't think we actually need to. I think it has all the information it needs without the insert in there. So I'm going to go download CAD. And I want to do the anti-collision model. All right, so we brought this in. And if we look over here, we have multiple bodies and components here. So if I just drop down this lower one, we have that body, and then we have this other body, which kind of represents where the inserts are going to be. So there's multiple ways to do this. I think the best way to do it is to just consider the upper body, let's see, this one, to be our actual tool holder. And then we'll use this to create a shell mill tool that attaches to that. So we're going to go into our Fusion Essentials, add tool holder, and we can call this one like, I don't know, face mill, whatever you're calling it. You can put in all this stuff again. Ericsson was the brand. And again, we're going to put this in our tool holders library. So the tool body is this. The axis, we'll just pick this. And then it wants to know the end face. So I'm going to turn off these other visible parts. In this case, it's a little bit different. So you might be tempted to call this the end face. This is actually the face where the lower body, the shell mill portion, sits against that face and indexes against that face, not this face. So I'm going to pick this face. And what this is actually going to do, it's actually going to remove this whole section of it. And this will be the lowest face. So let's click OK. Tool added to tool library successfully. That's good. So now I'm going to create a new design just so I can, I want to be able to come back and look at this. So I'm in my new design. I'm going to go to manufacturer just so I can get to my tool library here. And where do I have this? Tool holders. There's that face mill. And again, we need to fix the gauge length here. So preferably we'd want to get the gauge length from the vendor directly just so we're more accurate about this. So if I come back to this page, let's see. I can get the details. And here, I'm in inch. You can switch back and forth between inch and metric, but right here, gauge length is 2 inches, so that tells me it's got to be in an inch standard here. So back here, I'm going to change this to inches and call the gauge length 2. And that brings that right to there, which looks right to me. Okay, so for the sake of doing this, I'm going to create a new library, and I'm going to call this awesome mill. So in my awesome mill, I'm going to add a new tool. I'll do a face mill, and then I can put a description, awesome face mill. All right, so to fill in the next section on the tool library, we're going to actually just pull some dimensions off of here. So I can use I on the keyboard to inspect. So the diameter, so that's 2 inches. And then I need the length. This one's really important. So from there to the bottom of, make sure the inserts are turned on. So that length is 1.576. I'm going to write that down. And then there's the diameter of this upper section is 1.75. And I think everything else we can get to those details when we need to. I'm going to go back into the tool library, look in my cutter. So number of flutes, I think this was a 5 flute. Diameter is 2 inches. Shaft diameter, this is at 1.75. Overall length, this is the number I wrote down, is 1.576. Length below holder should be the same, 1.576. Shoulder length, let me call this maybe 1. Flute length, I think, is like, probably not the exact number, but I'm going to call it 0.75 here. Corner radius, I think it's 0.031. And that doesn't look exactly like our image because this kind of has a radius to it. But as far as simulating, this should be close enough for most purposes. All right, so now we're onto the holder. So I'm going to go look in my tool holders, face mill. I'll select that. And now this is kind of the point we were trying to get to, where we have a tool holder with a tool on the end of it. And this should closely enough represent what we need for our tool holder. It's got, the length should be very accurate. This little detail is maybe not quite accurate, but I'd rather have it stick out a little bit than not stick out. So I'll call that good. All right, so this particular toolpath is not doing anything that's too crazy where I'd be worried about a crash. But even for 3-axis stuff, there's times where you get a little close, and it's really nice to know the old saying, clearance is clearance. If you can simulate it, it's not going to guarantee you're not going to crash. It'll give you a little bit of extra confidence to make sure you're doing what you can to prevent a crash. So that's it for this video. Thanks for watching. Like, subscribe, all that stuff, and come back soon for more videos. Thank you.